Okay, now we're good to go. So let me put it on me for a second. Okay, so today, we're going to go over section 4.3. It's really more on simplifying logarithms. 4.2 and 4.3 are simplifying logarithms. And then when we get to 4.4, tomorrow we're going to solve for logarithms. So that's really what this leads us into. But I wanted to go over a few things. First off, again, the final is going to be December 4th when we get back from Thanksgiving break. It's going to be open that Friday. You've heard me say this every day, but there's going to be somebody in this class is going to email me and say they forgot it. So I've got video evidence. I've said it pretty much every day. The test 5. So test 5, I'm going to open up. Oh, I got to turn my phone on silent. Tomorrow we're going to cover 4.4, which is Wednesday, right? And then Thursday I'll open up the test, but we'll also have a review day. And I'll tell you, it'll be a much needed review day. Chapter 4 can be kind of daunting because of especially if you've never seen it before. So you need to hit that homework and then be ready on Friday to come in, or not Friday. I'm sorry, on Thursday to come in and ask questions because it's not the easiest section. Hold on one second, I forgot. And then Thanksgiving break. So again, they snuck Monday and Tuesday in there for Thanksgiving break. If you need me, I'll be available. Just email me. I'll meet with you. I don't mind going over things. And what I'm going to do is I'm going to have the test open from that Thursday until Tuesday of Thanksgiving break. So you'll have about 5 days to take it. Not a big deal at all. That gives you some time to get the homework done and get the material done and then to take it. Now, I'll tell you, though, the drop date for the class is the 20th. So if you're kind of iffy on if you should drop or not, the drop date is Friday. So I would get the test done, that Friday or Thursday, and just see what my overall average is. If you want to email me, that's fine. I don't mind looking at it and giving you my educated opinion on if you should drop or not. But just I need you to know that the drop date is the 20th in case you don't want to take a bad grade in the class and just you're going to retake it next semester. And again, if you do drop this class, you're not failing. That's not how it is. You're still in it. You just need to sign up for college algebra next semester. Do not take off any time. Don't take a few semesters off and then retake it, because then you're going to wind up being behind. Give me 1 second. My phone's not on silent. There we go. Okay. Okay, before I get started, I know I had Megan sent me an email about a question. Do you guys, Janie or Brianna, do you guys have any questions from 4.2? I'm telling you, I would get it done ASAP, because if you're not staying on top of this, it's going to really snowball for the test. These sections really kind of line up together. Okay, so I'm going to check this out. This is on page 467. Let me get to the camera here. Page 467, number 115, and it said we've got this function f of x equals negative 7.52 ln of x plus 53. And it says this models the percentage of first-year college men expressing anti-feminist views by agreeing with the statement. And that's X years after X equals years after 1969. Okay, so A, it says use the function to find the percentage of first-year college men expressing anti-feminist views in 2008. So in 2008. Round to one decimal, does this function value overestimate or underestimate? Okay, so now 2008, year since 2000 or 1969. So I'm just going to say 2008 minus 1969. That's going to be 39. So our X is going to be 39 because 2008 is 39 years since 1969. So I'm going to plug that in. F of 39 equals negative 7.52 ln of 39, right? plus 53. Now make sure that this plus 53 is not inside the ln. That would be a common mistake I'm sure that I would see if I asked this on the test. So let's see here. We've got negative 7.52 ln 39 parentheses. Make sure to close that parentheses. And then plus 53. 25 they round to one decimal place, so we'll do the same. 25.5. Now that's percent. So remember, this is percent of men who are expressing anti-feminist views. Now, if you go into the book, it gives you the actual percent from this survey. And the actual percent in 2008 is 26.2. So the actual from the survey in 2008 is 26.2%. So that means it underestimated it, right? It underestimated by what, 0.7%? So that's part A. So A, this is part of the answer. And then the other part is it underestimated by 0.7%, which is pretty close, right? Now let's look at B. B says, use the function to project the percentage of first-year college men who express anti-feminist views in 2015. So, okay, so we got to do 2015 now. So 2015 minus 1969. So that's 46 years later. So x equals 46. So I'm going to just go through the whole same rigmarole here. So f of 46 equals negative 7.52 ln of 46 plus 53. Ooh. So I'm going to pop that in my calculator. We get negative 7.52 ln 46 plus 53, 24.2. So it's lowering, right? So 6 would be 24.2%. And that's all it asks for B. So 24.2%. I think that answers your question about Megan. I hope that helps your question. At least you've kind of seen how to work it correctly. Okay. So do you guys, Janie, Brianna, do you guys have any questions before I go on to 4.3? Great. Okay, that'll work. Let me bring up the chat on the side so I can see it if you guys, yeah, like when you guys do pop something in there. Okay, so 4.3, really 4.2 and 4.3 can be in the same section. I'm glad your book broke them up because it would just be a lot of content for one section, but it just continues on with logarithmic properties. So just a quick review before we get going, what we learned in the last section, right? The properties we learned in the last section were log base b of 1 equals 0. That was the first property, right? The second property was log base b of b equals 1. The third property was log base b of b to the x equals x. Now, the one I didn't mention, and if you did the homework, you'll see it. And it's not going to pop up on the test, so that's why I don't really go over it. But it's if we have b raised to the log base b of x, it also equals x. That's really an exponential property, not really a logarithmic property. But we're going to extend these today. So and we're going to extend them with kind of expansion and contraction rules. So the first rule we're going to go over, so this is old stuff. The first rule we're going to go over is the product rule. And what this rule is going to do is actually expand a logarithm. So a single logarithm is going to turn into two logarithms, or three or four. It doesn't matter how many times things are being multiplied. So the way this looks is the rule actually looks is if we have log base b of any two things that are being multiplied, let's say m times n, okay? Log base b of m times n. This equals, and I have to write underneath because I have to expand it. If we have multiplication on the inside, it equals addition on the outside. Okay? Notice we've got log base b of m times n. We can expand this with log base b of m plus log base b of n. Now, eventually we're going to go backwards too. So you can do vice versa on this. Look, if we have addition of the same logs, we can condense them into a single log with multiplication. So we'll go expansion first, and then you'll see Later on, we'll come back and we'll do condensing, okay? So the questions for this section are going to say, expand the logarithm completely and simplify. Okay, so we'll do a real basic one. We'll call it A. Let's do real basics. Let's say like log base 2 of 5x, okay? Log base 2 of 5x. Well, notice these are being multiplied. And because they're being multiplied, we can expand them with addition. Okay, log base 2 of 5 plus log base 2 of x, right? Because there's multiplication on the inside. Notice the bases are the same, 2, and we got a 5 and an x. Now, we need to look at both of these and ask ourselves, hey, can we simplify either one? Look, log base 2 of x, no way that simplifies. There's nothing that lines up here. Log base 2 of 5, we can't get 5 into a base 2, right? If this 5, if you've done the homework, this will be more familiar. But if we've got a 5, if this 5 was, say, a 4 or an 8 or a 16, those are things we can get into base 2 and we could keep going, okay? But we're done here. This is it. We've expanded it completely and simplified it completely, okay? Let's look at one that does keep expanding, or keep simplifying, I should say. Let's say we had log of 100 z. Okay, log of 100z. So remember, if the log's by itself, there's really a base 10. And there's nothing wrong in you writing, like coming over the question and just writing log base 10. So you know what's going on, that there's actually a 10 there. There's nothing. It's not that there's nothing there. Okay. But we're going to look at this. So it's expand completely and simplify. So we see the multiplication on the inside. That's going to become addition on the outside. So log of 100 plus log x, right? Now, a log of 100 will simplify. You can put it in your calculator if you want, but we know that 100 we can write as a base 10. It's 10 squared. Log x isn't going to simplify. A variable inside is not going to simplify. So log of 10 squared, remember this is base 10. So these cancel. We're going to use this rule right here, right? If the bases are the same, they cancel, and it leaves you with the exponent. Bases are the same. We've got that 2 there. So we get 2 plus log of x. We've expanded this and we've simplified it, okay? We expanded it with the multiplication, multiplication into addition, I should say. And then we simplified the first term and simplified down, okay? So that's the first rule. Now, there's 2 more rules. The next one's pretty similar to this one. I mean, you can kind of guess it. If you've got multiplication on the inside and it becomes addition, a division is going to become subtraction, right? So if we had, let's say, hold on, let's write the rule first. So it's the quotient rule. And it says we've got log base b of m over n, right? So notice now we're going to have division on the inside. We got fractions on the inside, right? Log base b of m over n. And then we can actually write this to expand it. It's going to be the top minus the bottom. Okay? Top minus the bottom. So be careful. You got to make sure that subtraction's in the correct order, right? Because if we had something like, 5, we'll do this one down here. We had something like 5 minus 2 and 2 minus 5. These are going to be 2 different answers, right? 5 minus 2. Well, if we got 5, then we subtract 2, that's going to be 3. But then 2 minus 5 gives me a negative 3. So I have 2 separate answers. That's why you have to be careful with the order of subtraction. Okay, you have to be careful with the order of subtraction. So let's look at an example. Let's say we've got, now it's going to be the same. It's going to ask you the same, right? So expand and simplify. Expand and simplify. So if we had, let's say, log base 4 of 16 over y. Log base 4 of 16 over y. So look, we've got division on the inside, a fraction on the inside. So we're going to do the top minus the bottom. Okay, top minus the bottom. No big deal. Top minus the bottom. And then we have to see if either of these simplify. Look, the variable and the 4, that's not going to simplify. But the 16, we can write into a base 4, right? 4 times 4 is 16. So we get log base 4 of 4 squared minus log base 4 of y. Now to save some room, I'm going to finish it up over here. Log base 4 of 4 squared, that leaves us with a 2 minus log base 4 of y. I know, that's cool. You don't tell them. You don't have to tell them. Okay? Questions? Do you guys have any questions before I just give you some more examples? Oh, okay. Let's do one. We did a log earlier with a base 10. Let's do an ln. Let's say I've got ln of the square root of e over, let's say 5. The square root of e over 5. Okay, again, we've got division going on, so I know I'm going to use this rule. We got a fraction on the inside. I'm going to use this rule where we separate with subtraction. Right off the bat, though, look, this radical, I've got to write as an exponent. I'm going to just do that before I get going. Let's say the square root of e is e to the 1/2 over 5. Okay? And then now I'm going to separate, I'm going to expand it out. So ln e to the 1/2 minus ln of 5, right? Now look, I need you, and I know I mentioned this yesterday, but I need you to really understand or kind of notice that ln and e's cancel each other out. Remember, ln is just log base e. So we're really just using this rule right here when we deal with ln and e. They cancel each other out, okay? So ln and e cancel each other out. It's going to leave me with the 1/2 minus ln of 5, okay? Now this one, notice we have how many variables? It might ask us to approximate the answer. So this is the exact answer, okay? I'm going to box it in. But if your book asks you to approximate the answer, you could pop this one in your calculator. So let's do that. Now, 1/2, I'm just going to write as 0.5 minus ln of 5. Let's just round it to a few decimal places. Let's say negative 1.109, is that 4? Yeah, 4. So depending on what your book is asking, it might ask for the exact, it might ask for an approximate. So if it asks for an approximate, just pop in your calculator and you should be able to get that. That's not a big deal. Okay. Questions, comments, concerns? I'm going to give you a few before we go to this the last rule. I'm going to give you a few of these and I want you to try them. You can press pause if you need to. Let me steal some from the book. Okay, I'm stealing these straight from the book. Let's say we've got, actually, I'm not stealing them. I'm making them up. Log base 8. Okay, I'm stealing this one. 28 over x. B, let's do ln of x times the cube root of e. And then C, I'm going to combine these actually. Let's do a log of 100x over y. I want you to try these. I mean, it's okay if you don't get them right. Not a big deal. We're going to go over them. So use the rules we just talked about, and then we'll go over the last rule once we get that done. If you're working on it, that's fine. Just keep working. I'm going to see if I can get us through this. We'll use new color. It's new color time, Wrecker. Okay. So let's first, we got division on the inside. So we're going to say log base 8, 28 minus log base 8 of x, right? Now, I can't get a 28 into a base 8. That's not going to work. So we're actually done here. This is it. It looks like we could keep going, but we can't. Okay. We are done. Now, this one, though, is going to expand with addition, right? So we got ln x plus. Now, I'm going to write this as ln e to the 1/3, right? If it's a cube root, it's really 1/3. And then this last term simplifies, because remember, ln and e cancel each other out. It leaves me with the 1/3. Okay. And then lastly, we've got both things going on. We got top and bottom. So I've got log, remember that's really log base 10 of 100x minus log of y. Now, I can expand the log of 100x now. So log 100 plus log x minus log y. Okay. And then now we know log of 100, you can pop in your calculator. We did it earlier, right? 110 squared, that's just 2. So 2 plus log x minus log y. Kind of cool. Okay. Questions before we add the next rule? Comments, concerns? The next rule is not bad, actually. It's probably the most basic kind of rule. The last rule is called the power rule. Power rule is pretty simple. It says, power. It says if we have log base b of m, let's say raised to the x power, let's say these don't match. So we got a b and an m, we don't have bb. Remember, if these match, it just leaves us with x. Well, if they don't match, you can actually bring the x out to the front. It makes an exponent turn into multiplication. So x times log base b of m. Okay, kind of cool. So a really basic example would be, let's say we had log base 2 of 5 to the 3rd power. Okay, log base 2 of 5 to the 3rd power. Well, the 2 and the 5 don't match, right? So what that means is we can bring that exponent. We don't have to leave it in there. Now, when you're expanding it, you wouldn't leave an exponent inside the logarithm. You bring it out to the front. So this would become 3 log base 2 of 5, okay? And vice versa. Remember, we're going to get to a point where we're going to be given this and we have to bring it back in, right? That's like the next group of examples. We'll get there eventually, okay? Okay, so let's look at another one. Let's say we've got actually let me just steal one from the book. Okay, yeah. Like ln of the square root of x. So if we want to use this power rule, we're going to write this square root as an exponent. Ln of x to the 1/2. Now look, we can bring this 1/2 out front. Ln and x will not cancel. Remember, it was ln and e that canceled, right? So the ln and x won't cancel, but I can bring this 1/2 out front. It's going to be 1/2 ln x, which is a lot easier to deal with. You're not dealing with the square root stuff. Now you're just dealing with a multiplication integer, or not integer, but a rational number of 1/2. Kind of cool. Okay, let's do one more basic one and then we'll kick it up a little bit. This is a log of 4x to the 5th. Oh, this is a good one. So we're going to do a few different rules with this one. First, we're going to bring the 5 out front. But notice there's a multiplication going on the inside, but we have to be careful because the 5 is being multiplied to everything, okay? So this is going to be 5 times log base 4 plus, not base 4, but log of 4, and plus log of x. So this winds up being, you got to multiply the 5 to both, right? We expanded this one with addition, and then, or this logarithm with addition. But then the 5's got to multiply to everything. So it winds up being 5 log 4 plus 5 log x. Okay? 5 log 4 plus 5 log x. Okay. Brianna, Janie, you guys have any questions before I go on and just I'm going to mix and match all these different rules together. I'm going to try to throw in as many different types of examples so we can see as much as we can and see how your book, how this author really likes throwing curveballs at you. Okay. Okay. Let us see here. I'm digging the homework. I'm going to steal some straight from the homework. I'll give you the numbers for them. And they might have some of the examples. They might have none of the examples, but we're going to work through them. So the questions, this is section 1 through 40. It says use properties of logarithms to expand each logarithmic expression as much as possible. Where possible, evaluate logarithmic expressions without using a calculator. I don't mind if you want to use a calculator, that's fine. But it is, it's honestly a little easier sometimes to not use the calculator. So let me find some. Let's do number 12. I'm going to put these on here. I want you to try them, and then I'll go back and go over them. So if you want to start working on these while I write them down, that would do well. So log base 5 of 125 over y. That's a good example. Number 20. ln of the 7th root of x. Let's do. Oh, that's rough. Okay, yeah, that's not bad. Let's do 28. It's got a lot going on, but it's not that bad. Log base b of x cubed y over z squared. And 30. I don't know if I have enough room here. I'll probably have enough. Room here. So let's do 30. Let's do ln the square root of ex. Okay, let's try those. So I'm going to kind of give myself some room over here. That one. Okay, I'll give you a few minutes. Let's try these. See if we got it. If we can do it this way, we can do it the other way. Okay. One of those tap deals. Okay, Let's do this. We can do this. We can do this. We got this. Okay. So this first one, I'm going to have to kind of, I don't know where to write. Okay. Well, it's division. So we know we're going to expand it with subtraction. Oh, I got to write a little smaller. Maybe break out the little marker. Hopefully you guys can see this. I know this might be tough. But we got log base 5 of 125 minus log base 5 of y, right? Log base 5 of 125. Now, I got to see if 125 can be broken down to base 5. So I'm not sure. I think it is. So it's not 5 times 5. That's 25. Oh, but if I multiply 5 one more time, I get 125. So that means it's 5 cubed. So this would be log base 5 of 5 cubed minus log base 5 of y. So this first term turns into a 3. Log base 5 of y. Boom. Okay. The next one. I think I can use a real marker for this one. I've got to write it as an exponent. So remember that's 1/7 if it's the 7th root. And then look, I can't simplify here, but I can bring the 1/7 out front. So this would become 1/7 ln x. We did one just like that earlier, didn't we? Yeah, that's fine. Okay, this next one though has both things going on again. We've got subtraction and we've got addition up here. So let's divide it out first. So log base b of x cubed y minus log base b of z squared. Now I'm going to expand this out. This would be log base b of x cubed plus log base b of y minus that last term, log base b of z squared, right? So the x cubed and plus the y, right? X cubed plus the y. Now I've got to get rid of the exponents. I can bring these exponents out front. So this would be 3 log base b of x plus log base b of y minus 3 log base b of z. Right? Boom, shakalaka. Questions so far, guys? If you have questions, it's fine. I promise no one gets this right off the bat. This is very unusual to kind of just have click. If it clicks, that's great, though. Pat yourself on the back. If you're getting these right, no issues. Pat yourself on the back big time right now. Especially if you've never seen these before. Okay, so let's look at this last one. We got ln. Now I've got to think of this as ex to the 1/2, right? So I'm going to distribute bring the 1/2 out front. And then I've got to break apart the ln e plus ln x. Okay, I know I kind of zoomed through that, but so notice I first made this square root as an exponent, and then I brought it to the front. That was the power rule, right? And then I've got multiplication going on in here. Okay, so I've got to break that apart with addition. So ln e plus ln x. But remember, the 1/2 distributes through. Now ln and e cancel each other out. There's really a 1 there, right? So this becomes 1/2 1 plus ln x. Okay. And then I distribute the 1/2 through. And I get 1/2 plus 1/2 ln x. Boom. Okay. Where did the 3 come from on the end of the 28? That's a great question. I have no idea where the 3 came from. It should be a 2, right? It should totally be a 2. Thank you, Jenny. Boop. Fixed it. Okay. It's definitely a 2. Someone is watching this later on, Jenny, yelling at their screen, "That's a 3. Why is that 3 there?" And then they're going to go, "Oh, Jenny saved the day." Okay. Did I mess up anywhere else? I think I did. Oh, no. It's really easy to make goofy mistakes on these. You've got to be careful. Okay. Do you guys have questions about the other one, about 30? 30 is a lot like another one we did already, right? Where we had to bring the number out front and then expand it and then bring it back in. Okay, so now let's go the opposite way. So now we're going to be given, an expansion, and we're going to condense it down. Okay, we're going to condense it into one logarithm. So this is the next questions actually. So let's look kind of at a basic example. Would be really basic. Let's just do one with the power rule. Okay, so if I had like log base 2 of 7 plus log base 2 of x, right? So now instead of expanding and simplifying, we're going to condense. The questions actually say use properties of logarithms to condense each logarithmic expression. Write the expressions as a single logarithm with coefficients of 1. Now we do have to be careful. If you're going to condense, they can't coefficients of 1. So I'll show you what I'm talking about here. Let's put a 2 here. Why not? So 2 log base 2 of 7 plus log base 2 of x. Bring these together until I bring the 2 into that 7. Remember the opposite of that power rule? It's going to be log base 2 of 7 squared plus log base 2 of x. Now I can condense it down. Now 7 squared we know is just 49. So look, I've got the same base. So I can bring that together as 49. I'm just writing 7 squared is 49 x. 49x, okay? So we condensed it down into a single base, okay? Or not a single base, but into a single logarithmic term. Questions? Now, we might have to simplify. And 2, we have to check that. Like this next one, we'll have to simplify. We've got log base, or actually no log base, just log 250. This is number 42. Log 250 plus log 4. Log 250 plus log 4. So it's addition. So we're going to have to multiply on the inside. So it's 250 times 4, right? Now 250 times 4, that's 1,000, right? Now we could just pop this in our calculator because it's a log of 1,000. And we have the log button in our calculator. Should be 3. Boom, 3. Okay. So this just winds up with 3. So we condensed it and then simplified. Kind of neat. Okay. We condensed it into one logarithm and then simplified. They don't always simplify like that. But sometimes, every now and then, you might wind up with something like that. Okay, let's look at another one. Oh, yeah. This is number 56. 56 says 7 ln x minus 3 ln y. Okay? 7 ln x minus 3 ln y. Now, look, we can't have the coefficients like we talked about over here. So the first thing we have to do is bring the 7 and the 3 into the exponents. So we get ln x to the 7th minus ln of y cubed. And now look, it's subtraction, not addition. Subtraction. So when we bring it into a single logarithm, we condense it down, it's going to be a fraction, right? And that x to the 7th is on top and a y cubed is on bottom. Okay, x to the 7th on top, y cubed on bottom. Okay, let me give you one like that. Maybe that's a little different. Let's see if I can steal one. Oh, yeah, let's do this. 58. It's very similar. 58 says 2 ln x minus 1/2 ln y. So try that one, just to get one that's kind of similar there. Okay, so bring the 2 up here, 1/2 up here. So we get ln x squared minus ln y to the 1/2. It's subtraction, so we're going to do division. So x squared over y to the 1/2. Now I'm going to tell you, your book is probably going to make this y to the 1/2 a square root. It's probably not going to leave it as an fractional exponent. So it's going to say ln of x squared over the square root of y. And I believe the test generator software I use does that as well. Okay, so just FYI on that one. Okay, so just be careful. It won't be as bad. I mean, if you have multiple choice, it's not as bad because we know both of these are the same thing, and it's not going to be that one's an answer and another one's an answer. Okay. So the last thing we're going to talk about today actually is this change of base formula. Change of base formula. So the change of base formula is a way to get an approximation whenever we need an approximation. Like we need an answer that's not just a logarithm, but we need an actual approximation. This is a one way to do it with our calculator. So I use the ln. In your book, you can see if you're looking at kind of following along, you can use ln or log. I use ln. And the way it looks is like this. So we're going to go kind of back and forth here. We've got log base b of, let's say, m again. If we want an approximation, we can put it in our calculator as ln of m over ln of b. Okay? ln of n, or ln of m over ln of b. Okay. So let's say, and then actually we can pop this in the calculator. So let's say we had log base 2, let's say 15. Log base 2 of 15, which we can't simplify, right? 15 you cannot get into a base 2. So what we can do is, if we want an approximated answer, we can pop it in the calculator as ln of 15 over ln of 2. So we'd say ln of 15 divided by ln of 2, right? And we wind up with, now your book likes rounding this, I believe, to 4 decimal places. So 3.9069. Actually, yeah, 69. 3.9069. That's what the calculator's telling me that. 3.9069 if we round. Okay, we can check this too, just to see that we're right. And it's a good little review before the next section on how to go back and forth between logarithms and exponents, right? If I tell you that log base 2 of 15 is approximately 3.9069, we could write this as an exponent. So it should be 2 raised to the 3.9069 is approximately 15. So if we take 2 and then we raise it to 3.9069, you can see it's pretty dang close to 15, 15.00009 something like, right? That's close enough. So that tells me that this is the correct approximation. Okay, this is the correct approximation. Let's do one more. Let's say we've got like log, I'm going to steal one from the book. This is number 78. Log base pi of 400. And it states, in exercises 71 through 78, use common logarithms or natural logarithms and a calculator to evaluate to 4 decimal places. So this is going to be ln of 400 over ln of pi. So this is going to be ln of 400 divided by ln of pi. And we get 5.23. This would be 40, right? If we round it, 5.23, and we'd have to round that 9 to a 0, which rounds that 3 to a 4. So 5.234. I'm gonna check it. So this would mean pi to the 5.2340 should be roughly 400. So pi raised to the 5.2340 Oh yeah, that's close. 400.02, that's close enough. So that tells me that that is our approximation, okay? That is our approximation. Questions? I want to go backwards from this too, just because in this next section, we're going to be kind of asked to do that. So if I gave you, let's say, ln of 15 over ln of, we don't have to, we can use 10, whatever. ln of 15 over ln 10. If I wanted to write this as a logarithm, remember, so we're going backwards here. The denominator is the base, so that's the 10, and whatever's up top is inside the logarithm, okay? So if you get an answer of ln of 15 over ln 10, what this means is it's log base 10 of 15, okay? And you won't really see that in this section. That's not what this section is about, but we're going to see that pop back up where you go one way and you actually go the next way in 4.4, okay? Not too worried about that. So for homework, it's on page 477, 1 through 23, and then 29 through 35, and then 41 through 61, and then 71 through 77. I know I'm chopping these up, but it's for a good reason. And then the applications are kind of neat in this section. 103, 103. So tomorrow's section, we're going to do kind of the neat height example. That's in 4.4. We'll do the height example 4.4 for boys, and we will get Riker's height. Okay, so do you guys have any questions, Janie, Brianna, before I close this out?